In this video, I'm going to cover solving algebraic equations and inequalities. First, let's start with some one-step equations. Number 1, x plus 3 equals 8. Because we have 3 being added to x, we need to subtract 3 from both sides of the equation. Positive 3 and negative 3 add up to 0, and that leaves us with x equals 8 minus 3, which is 5. So 5 is a solution to this equation. We could always check this by plugging 5 in for x and seeing that 5 plus 3 indeed does equal 8. Number 2, negative 6x equals 24. Since negative 6 has been multiplied to x, we need to divide both sides by negative 6 to reverse that multiplication. And negative 6 divided by negative 6 is 1, and 1 times x is x. So our answer becomes 24 divided by negative 6, which is negative 4. Again, we could check this answer by taking the original negative 6, multiplying by negative 4 the answer, and making sure that it equals 24. Next, let's take a look at some two-step equations. In these problems, we have something multiplied by x and then another term added or subtracted from the x term. We're first going to get rid of that addition or subtraction by reversing it. So for number 3, 2x plus 4 equals 18, we will subtract 4 from both sides of the equation, bring down the 2x, 4 minus 4 cancels, bring down the equals, 18 minus 4 is 14. To reverse the multiplication by 2 times x, we will divide both sides by 2. 2 divided by 2 is 1, and 1 times x is x, and that leaves us with the final answer here of 14 divided by 2, which is 7. We could check this answer very quickly by multiplying the 7 times the 2 and then adding 4 to see that we do have the correct answer, since this leads to 18. Number 4, 5 times x minus 3 equals negative 18. Again, we will try to get rid of the term next to the x term to start with. To reverse the minus 3, we will add 3 to both sides of the equation. This leads to 5x, negative 3 plus 3 is 0, bring down the equals, and negative 18 plus 3 is negative 15. Next, we have 5 times x equals negative 15, so we have a 5 times x. We need to divide both sides by 5 to reverse that multiplication by 5. 5 divided by 5 is 1, and 1 times x is x. Negative 15 divided by 5 is negative 3. So this is our final answer. We could check it by plugging in negative 3 for the x, and we will get negative 15 minus 3, which is negative 18. So it checks. Next, let's take a look at a multi-step equation. Number 5, 5x plus 4 equals 10 plus 3x. We should notice that there's an x term on both sides of the equation. I like to start these by getting all the x's on the same side of the equation. I'm going to start by subtracting 3x from both sides in order to reverse this plus 3x on the right side of the equation. 5x minus 3x is 2x. I'm going to bring down plus 4 equals 10, and 3x minus 3x cancels. So now I'm back to what looks like a two-step equation here. All I need to do is reverse the plus 4 and reverse the multiplication by 2. I'll start by reversing the positive 4 by subtracting 4 from both sides. This gives me 2x plus 4 minus 4 cancels, bring down equals, 10 minus 4 is 6. Now I have a multiplication times x, 2 times x, that I need to reverse. So I will divide both sides by 2. 2 divided by 2 is 1, and 1 times x is x. So I get x equals 3, since 6 divided by 2 is 3. You could check this by substituting 3 for both x's. Next, let's try a multi-step equation involving parentheses. When we have a number directly in front of the parentheses, that means that we need to multiply that number by each term inside the parentheses. We do this first to clear out the parentheses and see what terms we have before we solve the equation. 3 times x is 3x. 3 times negative 3 is negative 9. We could write that as minus 9. 2 times 5x is 10x, and 2 times negative 1 is minus 2. Next, we see that we have x's on both sides of the equation. I'm going to start this by subtracting 3x from both sides to reverse this positive 3x term. 3x minus 3x is 0, so that drops out. Bringing down the negative 9, we have negative 9 equals 10 minus 3x is 7x, and I'm going to bring down the minus 2. Next, I notice that on the same side of the x, I have a minus 2. So I'm going to add 2 to both sides of the equation. Negative 9 plus 2 is negative 7 equals 7x. The negative 2 and positive 2 add up to 0, so that cancels. The last step here is always to divide by whoever's attached to x, which is positive 7. Dividing both sides by 7, we get negative 7 divided by 7, which is negative 1 equals x. That's the same as x equals negative 1, which is our solution. To check our answer of x equals negative 1, we place the negative 1 in both places where there's an x. Simplify inside parentheses, we have negative 1 minus 3, which is negative 4. And on the right side, we have 5 times negative 1, which is negative 5, minus 1, which is negative 6. If we multiply a positive times a negative, we get a negative, and 3 times 4 is 12. 2 times negative 6 is also negative 12, so this checks. Next, let's try solving some absolute value equations. When we have these absolute value bars in our equations, we need to be aware that we will probably get 2 answers, but we need to set up 2 equations to solve these. The reasoning here is that the absolute value of some number inside equals 8. That means the some number inside could have been 8 or negative 8, and that's how we're going to start this problem, is by writing out 2 possible equations. X plus 1 equals 8 or x plus 1 equals negative 8. We will solve both of these equations independently. To reverse the plus 1, we will subtract 1 from both sides of the equation. That gives us x equals 8 minus 1, which is 7. When solving this second equation, to reverse the plus 1, we will subtract 1 from both sides. But this time we will get negative 8 minus 1, which is negative 9. These are our 2 solutions, so x can equal 7 or x can equal negative 9. Both of these are true. If we plug in a 7 here, 7 plus 1 is 8. The absolute value of 8 is 8. Similarly, if we plug in a negative 9 plus 1 is negative 8, and the absolute value of negative 8 is also positive 8. So both of these check. For number 8, because the absolute value of x plus 5 has not been isolated yet, we need to get rid of the plus 2 as the first step. We will start by subtracting 2 from both sides of the equation. This gives us absolute value of x plus 5 equals 8 minus 2, which is 6. Again, we will use the same reasoning that we did on number 7. The absolute value of this number here equals 6. So this could either have been x plus 5 equaling 6 or x plus 5 equaling negative 6. We will subtract 5 from both sides of these equations to come up with our 2 solutions. X equals 1, 6 minus 5, and x equals negative 6 minus 5, which is negative 11. Both of these values should check. Before we solve some inequalities, we'll take a look at what the graphs of inequalities look like on a number line. It's important to note that when we have a less than or a greater than, these will graph with an open circle. When we have a less than or equal or a greater than or equal, these will graph into a bubbled in circle. To graph x is less than 2 on a number line, we should represent a couple points on the number line. And the nice thing about when x is on the left side of the equation is we know that we're going to shade the direction that this inequality points. So from the number 2, we're going to shade this direction. And because this does not have an equal bar, this is going to be an open circle. So another way to draw this is an open circle at 2 and shading on top of the number line in this direction. For number 10, x is on the left side, so we can go by the direction that this is pointing. -1 would be here, 0 and 1. That shows the direction of the number line. We know that we're going to have some sort of bubble at -1, and it will point to the right. We also know that because of the equal bar under the greater than, this will be bubbled in. So another way to represent this is to shade on the number line to the right. This represents all of the values that are equal to -1 and greater than -1. Let's look at how to graph a compound inequality. In this compound inequality, we have x is in the middle of -2 and 1. Therefore, the shading will be in between -2 and 1. We also see that we have an equals with this less than or equal to. Therefore, the bubble at -2 will be a solid circle, whereas the bubble at 1 will be an open circle because this does not have an equal, it's strictly less than. Since -2 is less than or equal to x, that means x is greater than or equal to -2. Now let's look at solving some inequalities. These two problems are very similar to two-step equations. They are two-step inequalities. So on number 12, we will start with reversing the +1 that is being added to x. We will subtract 1 from both sides of this inequality. We will bring down the 2x, +1 minus 1 will cancel. We will bring down greater than, and -11 plus -1 or -11 minus 1 equal -12. Next, we will reverse the multiplication by 2 times x by dividing both sides of this inequality by 2. X, bring down the greater than, and -12 divided by 2 is -6. If they asked us to solve this and graph it, then we would graph this on a number line. Every number greater than -6 is in that direction, and since there's no equal here, we will do an open circle at -6. For number 13, -5x minus 1 is less than or equal to 9. We will begin by reversing the -1 by adding 1 to both sides of the inequality. -5x we will bring down. We will bring down the less than or equal to, and 9 plus 1 is 10. Next, we will divide both sides of this inequality by -5. But there's a rule that everyone needs to know, that when you divide by a negative number or multiply by a negative number, when you have an inequality symbol, it will change the direction of the inequality. So negative divided by negative is positive, 5 divided by 5 is 1, 1 times x is x. This reverses from less than or equal to greater than or equal to, and 10 divided by -5 is -2. So the final answer is x is greater than or equal to -2. If they asked us to graph this, every value greater than or equal to -2 would be to the right, so the shading would be to the right, and we would also need to bubble in the -2 value. For our last problem, we will solve a compound inequality. It's important to realize that this is two inequalities. -10 is less than x plus 6, and x plus 6 is less than 14. We could solve these separately and then put our answer back into a compound inequality. However, I prefer to do this as one problem. We can actually solve this compound inequality thinking of it as having a left side, a middle, and a right side. Anything that we do to any of these three sides, we must do the same thing to all three sides. In order to isolate x, we need to -6. Therefore, we will -6 from all three sides. -10 minus 6 is -16. Bring down the less than. 6 minus 6 cancels, giving us an x in the middle. Bring down this other less than, and 14 minus 6 is 8. This is the solution to this compound inequality. If they asked us to graph our solution on a number line, we would have -16 on the left, 8 on the right. We would shade in the middle, and since neither of these have an equals, they would both have an open circle. That's the visual representation of all the values that are in between -16 and 8, which do not include the value -16 or the value 8. I hope these 14 problems give you a better understanding of solving equations and inequalities. If you found this video helpful, please like and subscribe for more math content.